All right, number 8. We want to simplify, assume that all radicands are non-negative. Okay, so we start out with the square root of sine 8, sine to the 8th power of x times cosine to the 3rd power of x. And then that is also being multiplied times the square root of cosine. Square root of cosine to the 3rd power of x. Okay, so being that both of these are under a square root, we can multiply them together and you will combine like terms. So just assume that cosine is like a variable, and when you multiply, just think of it like an x cubed times x cubed, you add the variables. So first I'm going to combine these two radicals. So the first step, I will end up with the square root of sine to the 8th power of x times cosine to the 6th power of x. Okay, now you need to understand what square roots do. We look for 2 of the same number. So it's understood to be a 2. So anyway, if you have a square root or radical, whatever number is on the outside is going to divide the exponent on the inside. However many times it goes in, it comes out of the radical. Anything left over stays inside. So if we do this 8 divided by 2, that will give us 4. It goes in there evenly. So outside of the radical now, we will have sine of 4 to the 4th power of x, because 8 divided by 2 is 4. And then we'll do the same thing with the cosine. 6 divided by 2 will give us 3. So we can say cosine to the 3rd power of x. And so that's all we can do as far as simplifying. So we get sine to the 4th power x, cosine to the 3rd power x. Sine to the 4th power of x, cosine to the 3rd power of x. All right, number 9 wants us to rationalize the denominator. So we'll focus on that part. So we have square root of sine squared y divided by 7, and this is all under a big radical, cosine squared y. Alright, first thing I would do is rewrite these with their own square roots. That's what this means. So sine squared y divided by the square root of 7 cosine squared y. Now from here I will reduce. I'm going to come over here, go across. The square root of sine squared will just give us sine. So on the top we will have sine of y. On the bottom, the square root of cosine, this is kind of like, another way to see this is like the square root of 7 and times the square root of cosine squared y. Like they both can also have their own. But I'm looking at the cosine squared, and it's also a perfect square. So I will do cosine of y times the square root of 7. So when it wants us to rationalize the denominator, we don't want any square roots on the bottom. So what we would need to do to get rid of that square root is multiply by itself. So we're going to multiply the top and bottom by the square root of 7. Alright, so what happens is we get sine of y square root of 7 over, this will be cosine of y, and then 7 times 7 gives you the square root of 49. Alright, and the square root of 49 is a perfect square. A couple different ways you can think about it, but the square root is just going to go away because 7, another way of thinking about it is the square root of 7 squared, and they cancel each other. But the same thing will happen here. So I'm going to come down one more step, and I'm going to say sine y square root of 7, and then the square root of 49 is 7 over 7, and we normally put the numbers out front. 7 times cosine of y. Now, we could do one more thing. We can simplify. This is a trig identity, sine divided by cosine. That's the same thing as tangent. So we could go as far as saying tangent of y times the square root of 7 divided by 7. Okay, that's another way to write this. So we'll see which form they want. If we go all the way to the end, that will be the best way. I'm going to try that one first, and then if not, I'll backtrack. So we'll say tangent y times division bar square root of 7 divided by 7.